All right, so for this last video, we're looking at qualitative graphs. Graphs can describe real situations and show relationships between two variables. When you draw a graph without actual data, so without numbers, this is called a sketch. And a sketch gives you an idea of what the graph will look like. So here, we have a sketch. We don't have any axes that are labeled, but it's just a general idea of what this graph is going to look like, whatever this information is. Now we can talk about qualitative graphs. They are graphs used to represent situations that do not actually have numerical values. They might have numerical values, but they don't have to. They also represent just the essential elements or the important information from a graph. So for example, we have graph A here, and this could represent a car that is accelerating at a constant rate. So we have to look at time. So time continues on and the speed of the car. So the car is speeding up, it's accelerating, and it's accelerating at the same rate, so it's a constant rate. So given that the graph represents water level in a bathtub over time, describe the change in the water level over time. So first it says you added more hot water to a partially filled tub. So this tub already had some water in it, so we're starting here, not at 0, but there's already some water in it. So you added some water to it. You relax in the tub for a while, which means you turn the water off, and it's constant. The water level stays the same. And then you drain the tub so all the water comes out. So if you're looking at the directions that this line is going in, it's increasing when you put water in the tub. It's constant, does not change when you turn the water off. And then when you drain it, the water level decreases. Example 2. The graph displays the number of people at a restaurant, so the number of people at a restaurant during the morning and afternoon. Describe the change in the number of people over time. So we're looking at the number of people over a certain amount of time. So in number 1, people enter the room at a constant rate. So the number of people is increasing. Then everyone stays for a while and eats. No one new comes in, no one leaves. They're just all there eating. So it stays constant. 3, most people leave at the same time. So the number of people decreases very, very quickly. The rest of the people stay and continue eating, but no one else comes in. So it's constant. And then a large group of people enter the dining room again. So the number of people quickly increases. Example 3. The graph shows a sketch of the following situation. Charlie walks to Jaden's house and they ride the bus to school together. Identify the letter that matches how the graph relates to the story. So, the first thing we have is that the bus stops. So we're looking, if the bus is stopped, the distance is not changing. So we're looking at your distance from home over time. So if your distance is not changing at all, that matches up with section D. Charlie gets to Jaden's house and waits for the bus. So again, this one's constant too. This one could match up with B. So for the first one, we'll say B or D. And for the second one, we'll say B or D. And then we'll come back and clarify those later. Charlie walks to Jaden's house at a constant rate. So he's walking, his distance is increasing, and he's walking. This matches up with part A. So he walks to Jaden's house first, so that's part A. So it says the bus resumes at the same rate. So we're looking at, if it's resuming, that means it's speeding up, it's increasing. So we're looking for a line that looks like a line before it. And it looks like E looks a lot like C, so this one would be E. Charlie and Jaden are riding the bus to school. That would be C. It's our only one left. And it's the same rate as E. So let's go back to 1 and 2. So I'm going to erase what I had so we can clarify. So he's walking to Jaden's house first, and then they wait for the bus. So they haven't gotten on the bus yet. He walks to their house, and then he waits. So that one is actually going to be B. And then the bus stops, so that would be at D. So walking through this one more time, at point A, Charlie walks to Jaden's house at a constant rate. Then Charlie gets to Jaden's house and waits for the bus. C, Charlie and Jaden are riding the bus to school. Then the bus stops and then resumes at the same rate. Now try some on your own. The graph shows the number of hot dogs sold, so number of hot dogs sold at a stand on different days. Part A, what is the greatest increase in the number of hot dogs sold? Between which 2 days does this increase occur? So, the greatest increase we can see is between day 6 and day 7. Got a little bit bigger. Between day 6 and day 7. And what is that increase? It goes from 40 to 90. So from 40 hot dogs to 90 hot dogs in a day. Part B, between what days is the graph horizontal and what is happening on those days? So we can see, it kind of looks like the graph disappears, just the way that it looks. It's horizontal between day 8 and day 11. So it stays the same between day 8 and day 11. And what's happening there? What's happening is that on all of those days, they're selling 90 hot dogs. So what's happening is that the amount of hot dogs sold stays constant. The graph below represents the time in minutes it took Christine to get from her house to the office, including the time it took to pick up her 2 friends, Laura and Jim, along the way. The y-axis represents distance traveled just by Christine over time. Part A. In which portion of the trip did Christine have the highest average speed? So it's saying which where is her line the steepest? And that's between 15 and 20 minutes. Part B. What do the horizontal lines after Laura's house and Jim's house represent? So she goes to Laura's house and she stopped. She goes to Jim's house and she stopped. So what that means is that she's waiting for them to come out of their house. Part C. How many miles away is Laura's house from Jim's house? So the distance is in miles. Laura's house is at mile 2. Jim's house is at mile 6. So they are 4 miles away. Part D. How many miles does Christine live from her office? So Christine is leaving from her house at 0. Her office is at mile 9. So Christine lives 9 miles from her office. So for these next few, you're going to try to figure out which story matches with the graph. So all of these have the same axes, and they're all about Tom. So we're looking at his distance from home over time. Every single time, it's his distance from home over time. So with this graph, our options are A, Tom skateboarded from his house, gradually building speed. Then he slowed down to avoid some rough ground and sped up again. B, Tom left his home for a run, but he was not fit and gradually came to a stop. C, Tom walked to the store at the end of his street, bought a newspaper, then ran all the way back home. So the story that matches up with this graph is story B. So when we look at what he's doing, he's increasing. So he's starting to go for a run and is increasing, and then gradually comes to a stop. So he's increasing, but then he starts to slow down slowly, and then finally comes to a stop. We landed up top because he hasn't gone home yet. So he's still far from home, but he's not on his run. He has stopped running. So here we have this graph. He's increasing, then constant, and then increasing faster. Tom walked slowly along the road, stopped to look at his watch, realized he was late, and then started running. Tom left his home for a run, but he was unfit and gradually came to a stop. Or after the party, Tom walked slowly all the way home. So the story that matches up with this one is A. So Tom is slowly walking along a road. He stopped to look at his watch, which means he's not moving. And then he realized he was late. He started moving again. His distance increased again, but at a much faster rate. Tom walked slowly along the road, stopped to look at his watch, realized he was running late, and started running. Tom walked to the store at the end of his street, bought a newspaper, and then ran all the way back. Opposite Tom's home is a hill. Tom slowly climbed up the hill and walked across the top, and then ran quickly down the other side. So what's happening in this graph is we have an increase, but a slow increase. Then we have a faster increase, and then an even faster increase in distance. The one that matches up here is C. So if we're looking at the first one, Tom was walking slowly and then stopped and then started running. That doesn't look the same. Here we have Tom walked to the store, bought a newspaper, and then came back. Here we have that he's going up slowly, up faster, and then up even faster. That one looks more like the graph that we have. A. Tom skateboarded from his house, gradually building up speed. He slowed down to avoid some rough ground, then sped up again. B. Tom left his home for a run, but he was unfit and gradually came to a stop, not home. C. Tom walked to the store at the end of his street, bought a newspaper, and then ran back. So with A, Tom skateboarded from his house, gradually picking up speed, which means there's a curve, and then he slowed down. B, Tom left his house for a run, realized he was unfit, and then came to a stop. Oh, and A, I missed one part. It said then he sped up again. So it would go up again. In C, he goes to the store. He's there for a while to buy a newspaper, and then he turns around and comes back home. So your answer is C. A. Tom skateboarded from his house, gradually building up speed. He slowed down to avoid some rough ground, then sped up again. B. Tom ran from his home to the bus stop and waited. He realized that he had missed the bus, so he walked home. C. After the party, Tom walked slowly all the way home. So if we look at what's happening, Tom skateboarded from his house, gradually building up speed. Then he slowed down, and then he sped up again. B. Tom ran from his home, realized he missed the bus, and then he walked home. C. After the party, Tom walked slowly all the way home. So your answer here is A, because it looks the most like the graph we have. A. After the party, Tom walked slowly all the way home. B. Tom ran from his home to the bus stop and waited. He realized that he missed the bus, so he walked home. C. Opposite Tom's home is a hill. Tom climbed slowly up the hill, walked across the top, then ran quickly down the other side. So if we're looking at what's happening, after the party, he walked slowly all the way home. So you would just have one line. B, Tom ran to the bus stop and waited. He missed it, so he walked home. Then we have this hill where he climbed slowly. Then he walked across the top a little bit faster. And then he ran to the other side. So the one that looks most like this is B. A. Tom skateboarded from his house, gradually building up speed. He slowed down to avoid some rough ground, then sped up again. B. This graph is just plain wrong. How can Tom be in two places at once? C. Tom walked to the store at the end of his street, bought a newspaper, and then ran all the way back. So process of elimination and what we've used before, your answer is B. But also the reason that it's wrong is because he can't be at the same time. He can't be at this distance and this distance at the same time. It just doesn't work. So your answer is B. A. Tom walked slowly along the road, stopped to look at his watch, realized he was late, and then started running. B. Opposite Tom's home is a hill. Tom climbed up the hill slowly, walked across the top, then ran quickly down the other side. C. Tom went out for a walk with some friends. He suddenly realized he'd left his wallet behind. He ran home to get it, and then he had to run to catch up with the others. So the only one that really makes sense here is C, because he was walking with his friends. He had to go, so he started at home. I'll draw a little house. Started at home. He walked away from home with his friends. Forgot his wallet. Had to run home faster, and then his friends kept moving, so he had to run even faster to catch up with them. A. Tom walked to the store at the end of his street, bought a newspaper, and then ran all the way back. B. Tom left his home for a run, but he was unfit and gradually came to a stop. C. After the party, Tom walked slowly all the way home. The answer here is C. So he starts away from home, and then he just walks at the same pace all the way until he gets there. For this one, I want you to write your own story for what Tom did.